Hello, I'm Mr. Bob, and welcome to my Algebra 1 video series. This video covers Chapter 1, Section 9, titled Graphing Data on the Coordinate Plane. By the end of this video, you will have reviewed methods for graphing points on a coordinate plane and analyzing data using scatter plots. To those ends, you will review the process of identifying coordinates, graphing points, identifying quadrants, and making scatter plots. Additionally, you will review a real-world problem where you will make use of scatter plots to identify trend lines and determine the correlation of data to those trend lines. If you'd like me to cover any of these topics in greater detail, please leave your request in the comment section below. Please subscribe to this channel and leave a like if you find this video to be helpful. Thank you. So before we get started into this review, I'd like to go over some definitions. So a coordinate plane. Two number lines that intersect at right angles form a coordinate plane. So let me see, maybe I can draw one here. Let's see. A coordinate plane. So what we have is we have a line going this way. And if I can draw a nice line coming down there. And these are arrows at the end of the lines, these number lines, kind of indicating that they go forever, right? And since these are number lines, I'm going to say 1, 2, 3, 1, 2, 3, -1, -2, -3, -1, -2, -3. So this is 3, this is -3, right? This is 3 up here, and this down here is -3, right? So the x-axis is the horizontal axis. So this is the horizontal axis. I'm going to put the label right here, x. And the y-axis is the vertical axis. So the vertical axis here is the y-axis. The origin, the axes intersect at the origin. The origin is this point right here. That's the origin. Okay. Quadrants. The intersection of these two axes divide the coordinate plane into 4 sections called quadrants. Well, you see these two lines have made 4 quadrants. The first one here is quadrant 1, quadrant 2, and we do it in Roman numerals, by the way. Quadrant 3 and quadrant 4. Okay, that's kind of how they define them. And then ordered pairs. An ordered pair of numbers identifies the location of a point. So if I pick a point here of, let's say, right here, -2, I'm going to say -1, -2. So it's -1 right here, 1, -2 right here. So I'm going to pick this point right there, and I'm going to call that point -1, comma, -2. There's an ordered pair. You all know what ordered pairs are. Ordered pairs of numbers, and that defines that point right there. Okay, and the coordinates, the ordered pairs define the coordinates. So when they talk about what's the coordinate of the point on your number, on your graph, the ordered pair is that definition. Okay, hopefully that helped. So objective 1, graphing points on the coordinate plane. So in this slide, you're going to see pretty much exactly what we just went over on the definitions. But it doesn't hurt to go over it twice. These are very important to understand. Okay, so two number lines that intersect at right angles form a coordinate plane. So here we have, remember I showed that in the previous video. We've got the right here, we got this right here, and these are the two number lines, right? They're intersecting. The horizontal line, the horizontal axis is the x-axis. So this is horizontal here, and this is x, right here, x-axis. And the vertical is in the middle here going up and down. And as you see, that's the y-axis. The axes intersect at the origin. Right here's the origin. Okay. And it divides the coordinate plane into 4 sections. Quadrant 1, 2, 3, 4. And as you recall, I said that they're in Roman numerals. So Roman numeral 1, Roman numeral 2, Roman numeral 3, and Roman numeral 4. Okay. An ordered pair. Now we're going to go down and talk about ordered pairs. It says an ordered pair of the numbers identify the location of a point. These numbers are the coordinates of the point on the graph. So point B has the coordinates of -2 and 4. And -2 is x, and 4 is y. Okay, it's our ordered pair. So if you look over here, you're going to see that -2, point B is way up here. I'm going to change the color. Maybe I'll change it to red. Or maybe dark blue, this blue here. So way up here is the point B that we're talking about. And to get to point B, we're going to go -2, right here, -2. That means from the origin, we're going to go on the x-axis. That's the first term, is x. We're going to go -2. That's 1, 2 to the left. And then we're going to go 4 up, positive. 1, 2, 3, 4. Here we are. So B is the name of that point, and it's at -2, 4. Okay? The x-coordinate tells you how far to move to the right or left. So it's right for positive and left for negative from the origin. And the y-coordinate tells you how far to move up or down, which up is positive, down is negative from the origin. And here's you can see the definition of our ordered pair right here. The ordered pair, -2 and 4. And so the first term, the -2, in this case, -2 could be a 5. It could be any number, but it happens to be -2 here. And that's our x-coordinate. And it's also called the abscissa, which you don't hear that term too much anymore. At least I haven't. The x-coordinate, but it is and could be called the abscissa, and the y-coordinate is the second term, or the ordinate. Abscissa and ordinate. Okay? Okay, example 1, identifying coordinates. Name the coordinates of point Z in the graph. Well, there's a bunch of points on this graph. And how would we name the coordinates? We would just say that it could be something as, it's hard to see this on here. I'm going to say here, how about 2, 3? That's the coordinates. The abscissa and ordinate, right? Abscissa, ordinate. X-axis, y-axis. So we're going to go down here and we're going to find Z. And from the origin, Z is to the left 2. It's down here. Here's Z. It's to the left 2, which is -2. So we're going to write that down here. I'm going to say -2, comma, and it's down 3. Down is negative. -3. So there's the named coordinates. And down here it says the coordinates of Z are -2, and let me get something more visible here. -2 and -3. Okay? Good. Okay, example 1, check your understanding. So why don't you go ahead and stop the video and try to find these points and that are listed here on our 4 problems, and then list the coordinates like we just did on the previous slide. I'll wait for you. Okay, now that you're back, let's go ahead and see if we can do a few of them. So the first one here is T. Name the coordinates of point T? Well, here's T. I'm finding it. It's way over here. I'm going to do it in red. Here's T right over here. So I'm going back to yellow. And I think I am anyway. There's yellow. So T is from the origin, which is 0 here. 1, 2, 3 positive for X, and 1, 2, 3 negative for Y. So it's 3 positive, comma, 3 negative. X, Y, 3, -3. How about V? Where's V? V is right here. Okay, we can see V. V is -1 and +1. So V is going to be X, -1, comma, Y, +1. -1, 1. How about W here? We find W way over here. Okay, here's W way over here. W is from the origin. I'm going to count 1, 2, 3, 4. So that's +4. I can do it right here. 4, comma, and then it's up 1. 1. Paren. 4, comma, 1. 4 in X, 1 in Y. Now let's do Q. So Q is right here. Right here. Q is right on the y-axis there, right? So it's up 2 in y, but it's 0 in x. So it's 0 in x plus 2 in y. Good job. So example 2, graphing points. Graph the point A equals 3 comma negative 4. So how do we do that? Well, we go to the origin, which is right here. Here's the origin, right? And we want x for point A, we want x equal to positive 3. On x, positive is to the right. So we're going to go 1, 2, 3 to this point here. And then 4 down, negative 4 on y. 1, 2, 3, 4. So here we are, right here. So we've graphed the point. Move 3 units to the right and from the origin and move 4 down. Okie doke. Okay, example 2, check your understanding. Of course, you know that means I'd like you to stop the video and try it on your own. Graph the points on the same coordinate plane. So here's that same one we just looked at. It's got that first point A graphed out already, but now they want us to do point C, D, E, and F. So why don't you stop the video and try it, and when you come back, we'll do them together. Okay, I'm assuming you've done that and you're returned, so let's give it a shot. So point C is x is 0, y is 3. So we're starting here at x is 0, x right here is 0, and y is 3. 1, 2, 3. So here it is. Okay, this is point C. Okay, now let's do point D. Point D is 2 comma 4. X is a 2, y is a 4. So we're going to go plus 2 and 2 on x and plus 4. 1, 2, 3, 4. Right here is point D. Okay, now let's find point E. Point E is negative 1, negative 4. Point E from the origin, negative 1, 1, 2, 3, 4, negative 4. And this is minus 1, comma, minus 4, or negative 4. And there's our point right there. Okay, last point, F. Negative 3, 0. Negative 3 is the x-axis. It goes negative 1, 2, 3. And in y, it goes nowhere. It stays at 0. So it's right here on the x-axis. So this is point F. Okay? Okay, example 3, identifying the quadrants. So remember in those early slides, we had the quadrant was the 90-degree number lines, and then quadrant 1, 2, 3, and 4, they went counterclockwise around the coordinate plane. Remember? And the first one was in the upper right corner was quadrant 1. In fact, I can draw it right here. I'm just going to kind of draw it here. And this is 1, and this is 2, and this is 3, and this is 4. Okay? So it says, in which coordinate or on which axis would you find each point? So for problem A, it says negative 1, comma 5. So negative 1 is in the x direction, and 5 is in the y direction. Okay, so I'm going to look for it. It tells us what to do. It says that since the x coordinate is negative and the y coordinate is positive, the point is in quadrant 2. So it negative 1, negative 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So we're going from negative 1 right here up to 5. 1, 2, 3, 4, 5. Negative 1, 5. So there's our point, negative 1, 5. Which coordinate is it in? Well, it's not in the first coordinate, it's in the second coordinate. Well, anytime x is negative, it's either in 2 or 3. And then depending on what y is, if it's positive, it's 2, and if it's negative, it's 3. So you can kind of make that, anytime both are positive, it's quadrant 1. Anytime they're both negative, it's quadrant 3. Okay? And anytime x is positive and y is negative, it's quadrant 4. So let's do B. It says 0 and 3. Well, x is 0 and y is 3. So x0 is right here. I'm going to change colors. Okay. Did I get it? I think I did. There's 0. There's x is 0 and y is 3. So that means 1, 2, 3. That means it's going to put it right here. And it's not an either coordinate, is it? It's the x coordinate is 0. So the point is on the axis. It's not in 1 or 2. If it was either side of that line, it would be in one or the other, but it's not in either quadrant. Okay? Okay, example 3, check your understanding. So now they want you to do it, right? In which quadrant or on which axis would you find each of these points? So A, B, C, and D, I want you to stop. You're going to have to draw your own coordinate plane, right? It gives you a little coordinate plane practice. So go ahead and stop it, try it, draw your coordinate plane. When you get back, we'll do it again together. Okay, I'm assuming you're back now. In which quadrant or on which axis would you find each point? They just want to know the quadrant or what line is that on, right? But I'm going to go ahead and draw the coordinate plane. So, oh, there, one there, and okay, this is x, and this is y-axis. Here's the origin, and 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, negative, 1, 2, 3, 4, negative. Okay? So the first one says, problem A says -2, 0. So where is that? -2, 0. Oh, I'm going to change let's change to blue here. -2, 0 is right here. Well, it's on the line, right? So this is on the x-axis. It's on the x-axis. It's not in either quadrant. Should I put the quadrant names in? How about it? 1, 2, 3, and 4. Okie doke. So B, 4, -1. Well, x is 4. 1, 2, 3, 4, right here. -1, down 1. Right there. This is 4, comma, -1. This one here was what? This was -2, 0, right? -2, 0. So this is in the fourth quadrant. It's in 4. How about problem C? -3, -5. -3, -1, 2, 3, 4, 5 is down here. -3 is here. So we're going to say it's right here. -3, -5. And this is in the third quadrant. And remember I said that when they're both negative, it's in 3. And now this is 2.7, comma, 3.6. Well, 2.7 is somewhere right around in here. And 3.6, 1, 2, 3.6 is about here. So we're going to say that's about where it is. And it's in quadrant 1. Okay, and I can say 2.7, comma, 3.6. That's that point. Okay. Okay, objective 2A, it says, because there's another slide that follows this. Analyzing data using scatter plots. A scatter plot is a graph that relates two groups of data. To make a scatter plot, plot the two groups of data as ordered pairs. Most scatter plots are in the first coordinate. Okay, the first coordinate plane, or excuse me, are in the first coordinate of a coordinate plane. Sorry for reading that wrong. I'll read it again. Most scatter plots are in the first quadrant of a coordinate plane because the data are usually positive numbers. I walked 5 miles and whatever, and and something, and ate 3 sandwiches, right? So it's two sets of data. How far did you walk and how much food did you eat? And so that'd be like two different points you're graphing here. So that's what we're talking about. Okay, example 4, making a scatter plot. The table at the right shows data students collected on their test scores and the number of hours they watched TV the previous day. And so we're going to make a scatter plot of the data. Okay, so this is like, what kind of score did you get on your test and how much TV did you watch yesterday? And if you didn't watch TV, maybe you were studying, right? That's the idea of this little questionnaire they had their friends figure out. So, so for the for 2 hours of television watched, the test score of 80, right? They had a test score of 80. So plot 2 and 80. So they plot the first one, which is here, is 2. There's 2 and 80 is right here. So this is kind of like they plotted that one, got that tied. There we are. So it said the highest score is 100. We're way up here at 100, right? And so it says, so a reasonable scale on the vertical axis is 0 to 100, because you can get 0 on your test and you can get 100. But really, we could have gone 50 to 100, right? We could have done 50 or 40 because there weren't any scores lower. But they went from 0 to 100. And they labeled every uh, uh, 20 points labeled, right? Every 20 points being labeled. So here's 20, 40, 60, 80, and 100. So then they went through this score data over here on this little chart over here. You can't really see it real well, but it says hours watched TV, 0, test score 82, right? Hours watched, 0, test score 100. So you go over here and you say hours watched TV, 0, hours, this is 1 hour watched, 2 hours watched, 3 hours, 4 and 5 hours watched. So 0 hours watched, and one student got an 82. It says, oh, 92, sorry, right up here, 92. And the other one got 100. So they plotted those two dots. And then they went down, 0.5 hours watched, and they had an 89. So 0.5 is here, and there's the 89 right there. And then they plot them out. 1 hour watched is 82. They watched for an hour, and they got an 82 right here. And if you just go all the way around, over here on the second little graph over here, 2 hours watched, and 80, that's the one we first plotted. How about 2.5 hours watched, 65, 2.5 hours, and they got a 65 right here. So what you see is all these dots are being plotted. And they just took them one by one from the table. Well, this is a scatter plot. And you can look at the scatter plot and you kind of make a decision, can't you? You can see that, oh, the more TV they watched the night before, the worse their scores were. Now, does that mean that the hours watched TV made the scores worse? Or is that maybe the students that were going to score lower scores anyway spent more time watching TV? But that doesn't mean that one caused the other one, but there's a relationship. We don't know what was the causal purpose. Anyway, so that's kind of what a scatter plot does. Okay, check your understanding for example 4. It says use the data in the table at the right to make a scatter plot of the data. Well, this would be interesting. It's a little, I'm not going to ask you to go off and do it on your own. We're just going to do this thing and try and do it together. So we're going to start off with a bracket here, right? And we're going to go, and I'm going to do this, and then I'm going to go out here like this. And what did this mean? This little gizmo here says that the data before that, it's maybe a long piece of data, because we're going to start high up here. We're going to start, and let's put 57. 57. This is the daily newspaper circulation. Media in the United States, in the millions of newspapers daily distributed. And then let's go over here let's pick another one over here, say 60, I don't know, let's say 61. Okay. And then over here, we're going to do, this one is papers sold or distributed. And this graph over here going up and down is going to be number of households. Households in the millions. So that's per million, right? 10 to the sixth is a million. Okay. 10 to the sixth. Oops, 10 to the sixth. Millions. And we're going to start down here. We're going to say that we've got 40 million right about here. How's that? 40 and 80. So 40 and 80. And then up here, we don't know. We'll just guess it where the number is, right? 40 and 80, 57 and 61. So now we're going to do some plotting. So we're going to do the first year. In 1950, there was 54 million newspapers sold. So 54 is going to put it right. Let's change colors. Let's use, what do you want to do? Red? Is that going to work good? So we're going to do right here, right? That's 54 million newspapers. And we had um, number of households with televisions. And I've got it way down here at the bottom because this is 40 million. So this is 4 million. So I'm going to say it's, right about here on the line. That's why I'm kind of right on the line right there. And I'm going to call that the 4 million over here and 54 million newspapers. But then in 1960, we had 59 million newspapers. We're going to put 59 right about here. And it's 46 million. Okay, so we're going to go up here to, here's 40. Let's do here 46. So we got a point right about here. And then in 1970, the newspapers was 62. So we'll go right here and go up from there, and it's 59. So 40, 59, and then there was 79 right here just below the 80, and then there was 92 somewhere way up here. So these are all newspapers. So we have each time we have 62 million newspapers in circulation. That's right here. And in 1970, there was 59, and then 79, as you see going across, 59, 79 million, and whatever is 92 million over in here. There's the spots on the graph. And then finally, the last one was newspapers in circulation, 55. We're way back down here, but we're at 101. So let's say we're way up here. So the last dot's way up there. So that's plotting those dots out. It's not really a very good scatter plot here. There's not much correlation going on, but that's a scatter plot for that data. Okay, objective 2B. So now we're back to talking about our objective in this, what we're doing here, and analyzing data with scatter plots. It says you can use the scatter plots to look for trends in the data. So the three plots below show the type of relationships two sets of data may have. So positive correlation, we call it, is when the line is going up. That's this one right here. You see the line is going up, right? Here's our line. It's going up. And how do we get the line? We kind of pick a spot that's kind of even right in the middle somehow of the dots. And we have software programs and your calculators and things that'll do this for you. You'll find out that you'll be using, you probably have already found it out, that you can do scatter plots, put the data in a matrix, and it'll do the scatter plot for you, and it'll actually show you the line, the correlation. And in this case, it would be positive because it's going up, right? The slope is going, it's running positive and going up positive, right? They're both positive, it's going up. So positive correlation, in general, both sets of data increase together. Negative correlation, you see it's going down. It's going down in this direction, right? So that means it's negative correlation. In general, one set of data decreases as the other set increases. So as X is moving to the right, Y is going down. And here's no correlation at all. Sometimes the data sets are not related. And that's what they're just showing. It's just random dots. There's no way to draw a line through anyway. Like the plot we saw before that was like a no correlation on the newspapers. And what threw it off was that newspaper at 100 up there, right? In the TVs at 100 million, newspapers at 54 million it was, I think. So a trend line. These are trend lines. A trend line on a scatter plot shows the correlation more clearly. So if you see that line, you can kind of get an idea. And you can say anything that falls near that line, you can almost pick spots that you didn't know, right? You can say, well, it's kind of right there on that line would be the spot we would pick. We'll see. Maybe we'll see that in another slide here. Okay, example 5, it's a real world problem. So use the scatter plot below. You see the scatter plot and the line too. There is a positive correlation. Oh, I said, excuse me. Is there a positive correlation, a negative correlation, or no correlation between the age of a used car and the asking price of the car? So now it's kind of obvious to you, right? The older the car gets, right, the less money you paid for it, right? The price goes down, and this shows it. The price is going down, so the trend line is going down. As the car gets older, 2 years, 4 years, 6 years, 8 years, 10 years, the price started off, whatever, at a year or whatever, at 20,000. We did a long time ago, huh? Starts off and then it slowly goes down. Well, we drew a trend line in there. We had the calculator plot one for us. And now we can see that a 4-year-old car that started off at 22,000 is now worth right here on the line. It could, well, any one of these would work, but the one right on the line we would say is like around 11, 12, $11,000. Okay, so it says sketch a trend line to approximate the data. About as many points should be above the line as below the line. So that's kind of what they're doing here too. They're trying to say, well, you draw the line in here, and if it's in the middle, if you have 6 points above the line, you're probably going to have like 6 points below the line, or just to kind of make sure the line. But it has to be a straight line too. At least these are linear graphs. There are data that you can plot that's not. It's not linear. We'll see that in later examples. I mean, on in your course, you'll learn that. But right now, these are lines, and it's a straight correlation, and it's pretty straightforward. So the age of the car as the age of the car increases, the asking price generally decreases. There is a negative correlation between the age and the asking price of a car. Okay, example 5, check your understanding. So answer these questions. You can just stop the video and try it and come back and we'll talk about it. So in the graph, what does the data point at 4, 14,900 represent? And then for B, it says use the graph to predict the asking price of a 7-year-old car. We're just going to use the graph to kind of decide how much would a 7-year-old car cost. Go ahead, stop the video and try it. When you come back, we'll continue. Okay, I'm glad you stopped the video and gave it a try, so let's talk about it. So it says in the graph, what does the data point at 4, 14,900 mean or represent? It represents what? A 4-year-old car costs, oops, that's a C, sorry, costs $14,900. That's what that's telling us. And use the graph to predict the asking price of a 7-year-old car. So we're going to go on the graph over here to 7, and we get the 7, it's right here's the 7, and we're going to go up. Oh, right there, the graph is nice because it touches right there on the $5,000 line. So that means that according to this graph, the 7-year-old car should cost, the price should be $5,000. The 7-year-old car is $5,000. Okay? Good deal. Good deal.